everyone. So today's topic is uh, domain name system, right? So the last video we have discussed about IP addressing, right? So today we are going to discuss about a domain name system. So domain name system. So as we discussed, TCP/IP protocol uses IPv4 address, right? IPv4 address is a 32-bit length address, right? This is also called as a dotted decimal notation, where each 8 bits are separated by dot, right? But uh, imagine there are uh, thousands of uh, systems are connected in the internet, right? Thousands of systems or devices are connected in the internet, including mobile phones, right? PCs, laptops, tablets, etc., right? So it is very difficult to remember the IP address of each and every device that are connected in the internet, right? So domain name system is useful to identify a device with a unique name, right? With a unique name, right? So IP address is mandatory to uh, 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 connect to the internet or network, right? But it is difficult to remember the IP address of all the devices. So domain name system will be useful to map the unique name to IP address, right? So the domain name system, or DNS in short, is used to map a name to an IP address, right? So it basically consists of a table, right? So host file, so it consists of name and address, right? So what is the unique name that will be mapped for the IP address? For example, google.com. So google.com is allotted to the particular IP address, for example 0.0.0.1, right? So single host file maps a name to an address, right? So host file, imagine there are millions of devices that are connected in the internet. So if you store all the names and addresses in a single table or single file, that would be large to store in all the hosts, right? So it is impossible to update the changes that happens every time whenever there is change in the network or host file. So the solution is, instead of storing uh, all the host file in a single table or single file, right, can divide the file into smaller parts and store on different systems, right? Different systems. So host which needs mapping can communicate to the closest system, right? Closest. For example, a particular country will be considered as a region. For example, India, within India, so all the host files that are available in India can communicate close to the server which is located in India or close to India. Right? This solution is called as domain name system, right? Domain name system. The basic idea is to map a unique name to an address or IP address. In this case, there are few steps or procedures that has to follow, right, to provide a name to an IP address. First, user has to pass a name to the file transfer client. So you can assign a name to your host and pass it on to the file transfer client. Then file transfer client will forward this request to DNS client. Then the DNS client will communicate with the DNS server. So you know the basic client server architecture, right? The query gives a file transfer server name using the known IP address, right? Then upon receiving the request, the DNS server will respond for the query, right? Uh, then the response received from the DNS server will be passed on to the file transfer client and then to the user, right? So the two connections must be made. One is to map the name to an IP address, then to transfer the files, right? Then to transfer the files. So the namespace, the range of uh, names are unique names that are allotted for each and every device. So it is organized in two ways. One is called flat namespace, another one is hierarchical namespace. So flat namespace is assigned to an address. Name is a sequence of characters without any structures or spaces, right? So it cannot be used in large system, right? And it is centrally controlled to avoid ambiguity and duplications. So if the central controller goes down, the entire namespace will be collapsed. Whereas hierarchical namespace, each name is made up of several parts. So it is a combination of letters, characters, alphanumeric, etc. Right? The first part will represent the nature of organization. Second part will represent the name of the organization. Third part, departments, right? Fourth part, namespace, and the last one is suffixes and prefixes can be altered. So it is basically a tree-like structure, right? So it will start from the root, right? Domain name, first it will start with the domain name, then the department name, and then follow up with the organization, right? Then the country, etc. It will stop with the null string, right? Null string. So it can have up to 128 levels. So in binary representation, the levels will vary from 0 to 127, right? So the names are defined in inverted tree structure with a root at the top, right? Root at the top. So as I said, first name represents the nature of organization, second one represents the name of an organization, third one department of an organization, right? And it will end with a null string, right? Null string. So full domain name is the sequence of labels separated by dots, right? Sequence of labels separated by dots, right? And it will end with the root, right? Root. See, we have a different types of namespaces, right? .com, .edu, .organizations, .alpha, .org, .gv, right? So there are different types of domain names. One is fully qualified domain names, partially qualified domain names, right? So fully qualified domain names will always be terminated with null string, right? So null string, it will be terminated always by null string. This is called fully qualified domain names, whereas partially qualified domain names are not terminated by null strings, right? They will start from the node but doesn't reach the root node. So it will never terminate at the top or root node, right? So it is difficult for resolver to identify the missing parts using the partially qualified domain names, right? So we cannot use partially qualified domain names at all the times, right? So the DNS client will try to find the suffix before parsing the address. For example, if you type GOO, the DNS server will try to identify that you are typing, you are intended typing google.com, right? But it is not correct at all the times, right? So domain is basically the subtree of domain namespace, right? Domain namespace and domain is different words, right? Domain is the subtree of domain namespace, right? So the domain can be anything like .com, .edu, .organizations, right? So the domain is the node of the top of the subtree, right? So domain itself can be divided further into subdomains, right? Subdomains. So the root server will will give you the detail about the domains. So if it ends with .edu or .com or .org, then you can easily identify the domain of a particular namespace or a system, right? So zone means what a server is responsible for or has authority over is called zones, right? So .com, so under .com you can have several subdomains. So this is the area where it has the authority. So this area is called the zone for the particular domain, right? So zone is the contiguous part of the entire tree. So if the server accepts the responsibility, then a domain doesn't divide the domain into smaller domains, right? So domain and zone refers to same thing, right? Same thing. So the root server is responsible for the entire zone, right? So there will be some primary server and secondary servers. So the primary server has the full authority for the entire zone. So it is responsible for creating, maintaining, updating the zone files, right? Um, this, the secondary files will operate on back of the primary search, right? So the secondary servers is not responsible for creating, maintaining, updating the zone files. It will just considered as a backup for primary servers, right? So it will have the complete information about the zone from the primary server, but it doesn't create, update or maintain the zone files, right? So DNS is divided into three dominant sections: generic domains, country domains, and inverse domains, right? So under each domain we can have several zones or several subdomains, right? So country domains, for example, if you look at the United States of America websites, right, organizations, so CA.US, so that you can easily understand that a domain belongs to US, right? Whereas we have a separate domain called inverse domain. It is used to map an address to a name, right? So domain name is used to map name to an address, whereas inverse domain is used to map an address to a name, right? So this happens when the server has received a request from the client, right? So this type of query is called an inverse or pointer query, right? Pointer query. So resolution. So resolution means mapping a name to an address, right? So you will send a request, right? The file transfer client will send a request to allocate a unique name to an IP address. So the resolution is the process of mapping a unique name to an IP address, is called the resolution, right? So we have a component called resolver. So resolver is designed as a client server application, right? So so the resolver receives the mapping request, it interprets the response, right, to see the request is real one or not. Then it will try to fetch a unique name to the address, right? Unique name to the address. So there are different steps or procedures to map addresses to names, right? Recursive resolution and then iterative resolution, caching, right? So I don't want to get into deep of all these things. So we'll have a look at the DNS messages. DNS messages based on the query response or client server architecture. The query message consists of a header and question records, right? The response message consists of headers, question records, and the answer for the particular question, right? And authoritative records, right? So the question section consists of only two parts: header and question section. The response message, header and in addition to header and a question, answer for the question, authoritative section, and additional section, right? So basically the header size is 12 bytes, right? 12 bytes. The query message is usually denoted as Q. The response message is denoted as 1, right? So the address section will give you the response for the particular question, right? Authoritative section consists of the resource records from where the answer is generated, right? And it is present only on response messages, right? And it gives complete information about the domain name, about one or more authoritative servers for the query. So from where the information is given, right? Then additional information, if there is anything, any additional or control messages to be included, then additional information section contains those information. So that's all about domain name system. In the next video, we'll discuss more about file transfer protocol and other things. Thank you. If you have any questions, post it here. Thank you.